Marine paleontology allows us to peer into the past to see the organisms that lived before. It will enable us to understand their migratory habits, feeding habits, and regions of origin. It also allows us to see how creatures evolve and adapt over time. To better understand our current oceanic organisms, we must look into the past to know where they originated. If we know where they come from and how their ancestors lived, we can protect the current organisms that live on the planet. We can see how these organisms of the past survived environmental changes in the past and how their descendants may react to recent environmental changes. Using fossil records from different species, we can determine what the environment was like and how each organism played a role in their ecosystem. We can also connect with their other species and how with other species and see how they evolved throughout time.
Hi, my name is Jacob Wyman, and the discovery of fossils are important because it helps us understand where the creatures today have come from and how they have evolved. Also, to learn what life was like back then and to see how much the ocean has changed. The Pacific is where most megalodon teeth are also found, by the way, as a fun fact. What's also important about paleontology is like the fossils help us understand, and that as long as we can find a way to preserve them, we can keep making more discoveries of what happened back then, what the ecosystem and the food chains are like, to help teach us in more and maybe also solve future problems depending on, and also see what creatures of today are related to back then, like what their ancestors were, where they came from, and who they descended from.
Paleontology is a study of history of life based on fossils. Marine paleontology is a subfield of paleontology that focuses on the study of fossils and sediments of marine organisms. The most common marine fossils are gastropods, trilobites, and ammonites. While these are common, some are harder to come by depending on what depth they are found at. These fossils can be used to reconstruct past oceanic conditions and ecosystems. The fossils that scientists are able to find and study really give us a glimpse at what marine life was like long ago. Other fossils, such as brachiopods, are mainly found in marine sediments and are often used by geologists to date back rocks. Marine paleontologists can also help provide evidence of Earth's marine history and be able to support the theory of marine evolution throughout the years. An example of this would be the whale fossils, because scientists believe that these huge marine mammals used to be land-dwelling animals before they evolved into marine animals we know today.
Scientists and researchers find a drilling location based on their objectives. They study the sediment layers, exploring for resources like oil minerals and even examining tectonic processes. Each site selection considers factors such as water depth, geological features, and even the scientist's goals. A unique vessel is equipped with drilling equipment, laboratories, and living quarters for the crew. The drilling rig on the boat can be lowered to the ocean floor. They then drill wells into the seabed, and once a reservoir is reached, oil or gas can be extracted for further processing. Deep sea drilling is crucial for accessing valuable energy resources, but it also raises concerns for the environment because of the potential oil spills and the habitat disruption.
Deep-sea drilling lacks sufficient regulations regarding oil mining in the Pacific and causes the fossil record to be displaced or destroyed. There are many ways that we can be less invasive in how we obtain oil from the Pacific Ocean. Many indicator fossils that are used in biostratigraphy are then destroyed when drilled, which causes the fossil record to be impaired. These fossils could have been used and studied for more research. Examples of this include many species of benthic foraminifera found in the Pacific that are important fossils for not only oil drilling, but also paleoclimatology, paleooceanography, and lastly, paleobathymetry. Here are some commonly used indicator species that help with biostratigraphy in the Pacific Ocean. Ways that we can try and reduce the amount of stress that deep-sea drilling puts onto the environment includes promoting stricter laws regarding our navigable waters in the U.S. territory to ensure that each part of the ocean is protected. The ISA, which stands for International Seabed Authority, has regulated some of the mining going on around the seafloor and is a great resource for awareness. Other ways that we can better the deep-sea drilling process involves the use of robots that will strive to have a lower impact on the environment and the sediments below. With these stricter regulations and new technologies, we may be able to preserve any species waiting to be found that could be beneficial for learning more not only about our past ecosystems and organisms, but help us better understand our current organisms and their lifestyles.